Welcome everyone, I'm Saleha Javed and today we are going to talk about logic in reasoning and retrieval. The contents we are going to focus on are the details about reasoning and retrieval, different examples and algorithm and how logic works. Then we will move on to knowledge-based agents in artificial intelligence and we will see types of knowledge and how that knowledge is represented. So we have come across different problems in our real world scenario where there is a monkey which is sitting in an enclosed room. There is a chair in the room and a banana is hanging from the ceiling, a little too high for the monkey to reach it. So what do you think? How will the monkey will reach the banana without jumping? These are the problems where any living being has to come up with a solution to achieve the desired goal. And obviously here we can think that maybe the monkey will use a chair to step onto it to reach the banana. And we also have examples like where there is a factory which is producing some dolls, let's say about 300 dolls in every day, and they get an order of about 1500 dolls they have to make. And now how many days will it take to manufacture that number of dolls? And we need some type of algorithm or some type of thought process to achieve our desired goal. This is where we need algorithms and our logic to build algorithms on. So of course we can solve certain problems by inferring some results, and but how can we program machines to solve them? Human beings can think, human beings can divide and devise solutions, but we have to here train machines to think and to come up with their own programs to solve the problem. So the answer is here logic, rules and reasoning, and we have to teach our computers and agents to perform these actions in order to perform and execute the desired task. So we need to tell the computer what to do in terms of instructions that must appear to be super clear and be deterministic, that the machine should be able to understand and act upon it. And in order the instruction to be understandable, what we really mean here is that we will learn a few algorithms and execute them as we are or we would have been computers. First of all, let's see, we have different applications around us. For example, let's take some games. So how can AlphaGo win against human world champion and beat it? So how can a computer play chess against a human being and beat the person? And we also see how a navy, a My Navy, finds a way or a path while the game is going on. So these are the problems where we see the computer is devising their own solutions for the problems that they are targeted to solve. So in order to perform the action, the computer tries to search for a solution, and we have different examples of searching. We will start from the basic and understand how the computer is trying to learn the reasoning and logic. So you have in front of you a diagram of certain nodes where you see names of cities written into it. This problem is for traversing from one city to another, and we have some aerial distance between different cities, for example from Stockholm to Luleå, Umeå to Luleå, Luleå to Kiruna. And all these lines between these circles represent some distance between these cities. And the circles represent nodes, and nodes can have names in them. And the lines between these nodes are different edges, and these edges are of two types. They can be directed. That means that you can move from one node to another in one way, and they can be even bidirectional, that you can move back and forth between two nodes. And they can also be attributes as well. For example, the edges can have certain distance value which you have to take from coming from one city to another, and they can have different values, for example path cost as well, which we'll see later on. And a graph without a circle is a tree. Now what is a circle here? When we have to revisit a node between a path, that means it's a circle. We are going through the same node more than once. and that means that particular graph has circles in it, so it cannot be a tree. However, a tree which can never be, such a graph that does not have any circle is a tree. That is the difference between a graph and a tree. Now, let us see knowledge based agents in artificial intelligence. So, we have our agents. An agent can be any entity which we are training to take input from the environment through some sensors, and we are training it to act upon based on the information that it collects from the sensors and perform some action that can affect the environment, and that is how we define our agent. But an intelligent agent is basically a machine which collects knowledge about the real world, and it has the capacity for reasoning. It performs some computations and it performs some actions to decide what type of reaction it should give back to the real environment, and that it decides the ways to act. So, basically it has a reasoning mechanism inside it. Let's see what is happening inside our knowledge base. You see a white box in front of you where we have 3 different modules inside a KBE, which is a knowledge based agent, an inference engine, a learning, a knowledge based, and a knowledge base itself. So, basically it collects input from the environment, performs certain actions, and then reacts back as an output, as an action towards the environment. So, what does a knowledge base contain? It is a collection of sentences and knowledge representation language that is understandable to the agent. It has an inference engine which is generating new facts, deriving new sentences, adding them to the knowledge base. This is where the logic and reasoning is applied, and the rules are fired here. And lastly, we have the learning KBA. Here it basically updates the knowledge base based on the output that it is giving and based on the experience that it has. So, our knowledge based agent is continuously learning and improving its performance on its own as well. And now coming on to the types of knowledge that we have. So, we have declarative knowledge where we know about something, and concepts and facts. So, these are the known facts that we have. Then we have procedural knowledge, then how to do something. We have some information and we have to derive certain actions based on that information. So, we define certain SOPs or set of procedures, and defining those procedures we require procedural knowledge. Then we have structural knowledge, and this is based on the basic knowledge for solving problem. Then we have heuristic knowledge. This is the rule of thumb based on previous experiences. This is something you can say we develop or we set based on the reasoning which is outside the facts and figures. Then we have meta knowledge, which is know about the different types of knowledge. Let's see how knowledge is represented. So, we have different methodologies. First of all, simple relational knowledge, which you see in front of you in the table. We have 2 different agents, agent 1, agent 2, and we have set in the table that they have certain hobby and they have certain age. Agent 1 has reading as hobby and the age is 23. Agent 2 has games as hobby and the age is 49. This is one representation of knowledge. The second is inheritable knowledge. Here you see in front of you a tree or a graph type of thing, where we try to represent different facts about any entity or a person, or as I said, anyone, and then you try to represent it in terms of relational methodology. So, if we go from top to down, we will say we have an adult female who is a player, and if he is a basketball player, then that instance is Michelle. Then reading the second branch from bottom to top. So, Petra is an instant who plays football, she is a player and she is an adult female. So, this is how we represent the inheritable knowledge. So, while we are representing knowledge, as you saw in the previous example, we have to connect different facts with some relations or some rules when we are defining them. So, we need to have procedural knowledge about maybe how we are connecting facts, how we are connecting different events. So, either we represent them as small programs, or we use if and then else statements or loops to represent them. And then when we are trying to derive logic representations, we represent them through propositional logic or predicate logic. This was it for today. Thank you.